Okay, we're doing the specialist external paper from 2022, paper 1 tech free. I'm going to do question 16. It's a system of equations. And we've got a system of equations that it corresponds to 3 planes. We're asked to use Gaussian technique to determine the value of lambda, for which the system of equations has infinitely many solutions. Okay, infinitely many solutions. That's when we're going to get it looking like blah, blah, blah. We want it with zeros in the bottom line. There'll be 1 there. So we're looking for zeros in the bottom line to indicate infinitely many solutions. Let's put it into an augmented matrix to start with. That'll be 1, 5, minus 2, 1. 1 minus 3, 1 minus 3. Oh, sorry, 3, apologies. That's a positive 3 there. Then I have 0, 8. Bring this over here. I'll have 3 and I'll have lambda. So that's my first step, putting it into an augmented matrix. I now have to perform row operations with the view of I want a row of zeros. So as my first step, I'm going to leave my first row alone. I'm going to go row 2 is going to be row 2 minus row 1. So row 2 minus row 1 is going to give me my 0. Row 2 minus row 1. So negative 3 minus 5 gives me negative 8. 1 minus negative 2 is going to give me 3. 3 minus 1 is going to give me 2. Leave my bottom row the same. Just checking my negatives because you never... Oh, hang on. That should have been a negative 3 there, I just realised. Sorry. Because that 3 should have come over there and been negative 3 lambda. So that should have been a negative 3. Apologies for missing that negative. Now, I'm going to leave my top 2 rows alone. And then I'm going to change row 3, which is going to be row 2 plus row 3. I'm going to add. So from my previous, I'm going to add these together. So I'm adding these two. So 0 and 0 is 0. 8 and negative 8 is 0. 3 and negative 3 is 0. Lambda plus 2. So for infinitely many solutions, I want lambda plus 2 to equal 0. So therefore, I want lambda to equal negative 2. So that's the first part. I determined the value of lambda so that this system of equations has infinitely many solutions. That's part A. Part B. Use your result from part A to determine the infinitely many solutions and express your answer in the form of a vector equation of a line. It's very important there that you note that they want a specific form for the answer, the vector equation of a line. If we continue from where we had in part A, okay, so where I had it there, and we're going to say there are infinitely many. So 1, 5. So I'm just copying across because I haven't written it down before and I don't want to get any of my numbers incorrect. All right, so I'm 0, 0, 0. I have infinitely many solutions. I can simplify this a little further using Gaussian. Is probably where I want to go with this. All right. So I want a 0 here. Oh, actually, before I do that, I want a 1 here, don't I? So I'm going to want, go down here, I'm going to want row 2 to be -1/8 by row 2. So 1, 5, -2, 1 stays the same, 0, 0, 0, 0 stays the same, and this will be 0, 1, -3/8, and -1/4, because -1/8 times 2 is going to give me -1/4. I think I can simplify it further with my Gaussian if I keep going. My next thing, I'm going to leave my 0, 0, 0, 0, 0, 1, -3/8, -1/4. I want a 0 here. Okay, so I want to change my row 1. From our method, we're going to go -5 times row 2 and add it to row 1. We've often done this on our calculators, but we can do it without. So -5 times 0 plus 1 is still going to leave me with 1. -5 times 5 plus 5 gives me 0. Oh, this is a little bit of a trickier one though, isn't it? To do this one, we're going to have to go -5 times -3/8 plus -2. That's a lot of negatives, isn't it? So that's going to give me 15 on 8 plus -2. Well, -2 is going to be -16 on 8, isn't it? So that's going to be -1/8 in there. Just working out the second one, or the last one here. -5 times -1/4 plus 1. That's 5 on 4 plus 1. And that's 4 on 4, so 9 on 4. Okay, so a little bit of fraction work there. But if you get your fractions, write it out, and that'll be, make sure you're correct. So we'll just leave that there. So from now reading this, I've got x plus -1/8 z equals 9 on 4. I have y plus -3/8 z equals -1/4. I'm going to say let z equal k. So then I've got x plus -1/8 k equals 9 on 4. Y plus -3/8 k equals -1/4. How that looks in vector form: x, y, z, equals 1/8, 3/8, 1 k plus 9 on 4, -1/4, and 0. Oh, apologies, that was where my numbers go. I would have rearranged. Obviously, this is x equals 1/8 k plus 9 on 4. Y equals 3/8 k plus -1/4. And obviously z equals just k plus 0. So my x, y, z, this is my vector form. And that's that question done.